Hello everyone. Today I would like to talk about a few elements of machine learning that I use to do my assignment. So now first we have the dataset learning task. We work with a prostate cancer DNA micros array dataset. We have 75. We have the number of patients of the number of the variable, explicative variable. After, we use the binary classification in two parts. We have cancer versus a non-cancer. Typical, this is, summary we can do that is the typical small n and large p setting with a few examples and many future. Create high overfitting risk. Model complexity. Above the overfitting, we have the complexity model and validation are critical. Part two, we have unvariant statistical screening. As a first step, I use univariate statistics to understand which gene an individual must relate to the response. For each gene, we apply non-parametric cross-cal value state to compare its distribution between cancer and non-cancer patients. Gene with largest cross-cal Wally statistics are most discriminative. We are select top 9 or bottom 9 gene, then we use then then use comparative box plots to visualize the difference. About the top gene, the box plots show clear shift between class median are different. It's confirmed that the strong is confirmed that is confirmed strong individual discriminative for bottom 9 chain box plots for cancer and non-cancer are almost identical. About the correlation, we are look at the correlation matrix of the top 9 chain to understand dependence. Many pairs are strongly positively correlate. Some moderately negatively correlate. This indicates the multi-collinearity and redundance. Then we are compute the eigenvalue, the max I mean, after we do the ratio. We use is variance concentrated in few direction. We can compute effective dimensionality less than my. About the learning algorithm, we are used KNN and tree. Yes. After, first we are compared to family of supervised learning method. We have KNN Mabel. This is non-parametric method that classify by looking at K-close patient in gene express space. After, we have the decision tree. Recursively splice future space using threshold on gene value to form decision rule. After, we are used the tree and unvariance statistic. Interesting connection. The root node of all my trade use and gene this, not to remember. This gene is one of top crucial gene. Yes. We can say that small complexity parameters CP produce deeper tree. Large CP value prone and give simpler model that still use same K-gene. After we have used the performance evaluation ROC curve to evaluate discriminative ability, we are compute ROC curve for the 6 model and tree with CP value. All ROC curves lie clearly above the diagonal and are almost on top of each other. All models able to separate cancer from non-cancer is reasonable. Well, about the generalization and stability, We are using the dataset for both training and testing of is optimistic. I perform I perform 1,000 random. Yeah. 1,000 random above the box plot of the test error show. If you are 1 kk, if you are one nearest neighbor and unprint 3 more variable across speed. For another and prompt 3 more stable. But this illustrates the bias variance trade-off. Very flexible model adapt closely to data but are unstable. More regularization model are stable but may not reduce average error much. I run one way ANOVA on test error cross method. Yes. And then we have main conception takeaway. This exercise combine key idea in statistical machine learning. We have delayed with small n large p data. We're using statistical tests and correlation analysis for variable selecting. We compare non-parametric and tree bus classifier. We evaluate the model rigorously with ROC, repeat, split. Yes, and ANOVA. Main lesson. On this microarray dataset, several reason models achieve similar performance. Above, we can careful control of complexity and robust validation are more important than searching for a single magic algorithm. Thank you.